So, hi everyone. Thank you for joining me while technical support takes over our socials and answers your frequently asked questions. My name is Laura Carlton and I'm the head of training here at Horizon Discovery. And I'm joined by Yvonne Rubio, who has been answering our customers' questions for how long, Yvonne?
Ooh, 7 years, more, a
7 years?
little more than
Yeah.
that. Mm.
And then I have Jen Barca, who is the team lead for technical support, and she's been answering our customers' questions for
10 years.
10 years. So 17 years combined with these ladies. Extremely experienced humans. So I'm excited to hear what they have to say. So the first question I'm going to ask you guys is, how do I optimize cell lines for RNAi and CRISPR experiments?
I think the answer is similar for both.
Yeah.
Don't you, Yvonne?
Yeah, totally.
Yeah.
I totally agree.
I guess I would start with delivery. For either of those molecules, you got to know your cells. You got to know your growth conditions. You got to know your delivery conditions. So things like the cell density you want to grow them, if they're transfectable, what kind of transfection reagent, how much. I think that will really set up the whole basis for your success. Because with both of those techniques, the higher delivery efficiency you get, the easier the whole experiment is going to go. Don't you think so, Yvonne?
Yeah, I think so. But also, like, looking also on what's going to be the detection, and knowing a lot your protein. Like, are you going to expect your protein to kind of like have a long life, or when are you going to expect to detect actually? So I think not only at the beginning one needs to optimize all the conditions, but also look in the literature and see what's actually what are you going to expect, when are you going to expect that protein to be really even down regulated, or how are you going to do the detection finally. So I think all this can be studied, or yeah, one can read a little bit in the literature to find this as well, to set up the best conditions for your experiment.
And then can I add one? You made me think of the next step then too, is make sure you expand and bank those cells. If you've created something like a CRISPR knockout, make sure it's well characterized both on a molecular level, like you've done some sequencing to make sure you know the sequence is altered, and also some sort of a functional assay if you can, and bank them, because someday you're going to want to go back to that and it's not easy to reproduce.
And bank a load of them.
Yeah, exactly.
A load of them.
you will start counting actually the passage number of those cells. Yeah, so you will create them. You will start like really recording what's the passage number that I have now, how many tubes did I create for those, and then you can always go back to that. So you can also have it recorded. You can go back to that whenever you need it. One important thing is, depending on the gene that you're going to knock out, or if you create a stable cell line with shRNA, you could have like genes that are creating like instability, like your cells are going to be changing a lot. The phenotype is going to change. You may not understand what's going on because the genes are actually essential genes or something like this. So always having those cells banked is a good way to go back to what's happening.
Go back in time, kind of thing.
Yeah.
Yeah, I think one of the interesting things is when you think about it philosophically, when we talk to a lot of customers, they think that making that knockout is the experiment themselves. But it's not. You've just created the tool to fuel all of your future research that is going to be the basis. So just like, any tool or reagent, you want to make sure that you take care of it and have some ready for the future.
Yeah.
Exactly.
You brought up a good point of, kind of understanding your gene when it comes to optimization. And I completely agree, especially about the half-life of the gene. But do you recommend to optimize with, say, the gene-specific probe when it comes to siRNA and CRISPR RNA? Or do you recommend to use it with controls, like both with the like positive and negative controls as an optimization for transfection, etc.?
The first steps are always the controls. Yeah. So you always go to check what's the best transfection conditions and the best conditions to actually downregulate a gene of interest that is known, for example, a housekeeping gene. Yeah. That way you can be sure that the internalization of the reagents that you're using is perfect. So you have the best conditions for your cells. Yeah. Once you have that, so once you know what Jennifer was telling, the cell number in that specific plate size, yeah, the amount of reagent for transfection, the amount of siRNAs, the amount of CRISPR or tracer or sRNAs. Once you have all that, then you can move. You have a base. You have a base from which you can move to the next steps, which is actually doing either the downregulation or the knockout of your gene of interest. Yeah.
Because there's more complications when it comes to your gene of interest, right? I just saw your eyes explode there, Jen.
Absolutely. Or you wouldn't be doing the knockout in the first place, right? If we knew what was going to happen there, you just buy a reagent that already has that. But this is part of the experiment.
Perfect. Well, thank you so much. I think that was super helpful. I got all of my questions answered. So thank you, Jen, and thank you, Yvonne. So you can ask Jen and Yvonne any questions that you want all the time through our technical support. Contact us. And so you can do that through the chat button and through our 1-800
telephone.
What is it?
If you just go to the contact us on our webpage, you'll see your phone number. We have both regional phone numbers, and we have agents like Yvonne who speak multiple languages as well. But we also have email, technical@horizondiscovery.com, or as you mentioned, the chat.
So you can just go nuts.
Exactly. And we're all the time there, and we are super happy to help.
Well, thank you guys so much. I'll talk to you again soon.
Thank you, Laura.
Ciao, ciao.